The broadcast is now starting. All attendees are in listen-only mode.
Hey guys, I'm Christian from Procedural, and I'm going to tell you a little bit about Compute today. Compute is our platform for running building physics in the cloud. And today we are going to talk about running daylight, and specifically daylight factor simulations in the cloud. Yeah, and so here's a short agenda of what we're going to do today. So we are basically going to try to reproduce the picture you see to the right with these 9 office spaces or buildings. And we're going to set it all up with Honeybee Legacy, their legacy plugins. And then we're going to execute it in the cloud. So we're not going to run anything locally. We're just going to generate the files and then ship it off to the cloud machines. And in that way, we can basically get all 9 simulations back in the time it takes to do one, because we can do them all in parallel. So I'm going to give a short introduction to who Procedural is and what Compute is, and then I'm going to take you through the Grasshopper canvas, and then we're going to run these cases, and we're going to visualize them, download the results, and visualize them back in Grasshopper, and then hopefully that will be around an hour of our time. So just to tell a little bit about us, we are a small software engineering firm based in Copenhagen, and we try to help our clients with by building tools to lower the barrier to entry when it comes to making sustainable and environmental design. So we have 2 products on the market. We have Compute, which I'm going to show you today. And then we have Track for managing documents, requirements, and everything related to sustainability rating schemes. That could be LEED or BREEAM or DGNB. But today we're going to talk about Compute. And as I said in the beginning, Compute is a platform for running your building physics in the cloud. And we let you hook the cloud up with Grasshopper, and you can do it everything you need to do in your familiar workflow in Grasshopper, and then you can send off the simulations to the cloud. And this little diagram shows how it's done. So we have you here on the left with Grasshopper and our plugin, and then you communicate with our web server. And when you send messages with these simulation tasks to the web server, then the web server will set up the simulation machines. It will put your simulation case inside of one of those machines, and it will execute the simulation. And then when everything is done and you have your results, then it will shut it all down. And then it will basically notify you, and you can download results. So that's very simply how it works. It also means that you don't need to install anything on your machine. So typically, I've previously shown how we do CFD and wind simulations, and with that, we only use our own plugin. Today, we're also going to use Ladybug. So of course, you need to install that. But usually, if you only use our plugin, that's the only thing you need to install. You don't need to install any of those simulation engines that you are going to run. That's all installed and managed by us in the cloud. So it's a very lightweight plugin. And since actually since the last webinar we have made a roadmap of our upcoming development and features and analysis that we're going to implement on Compute. We have done that because we have been given a grant from the Danish government to continue development, and we thought that we're going to make what we're going to do public. So it's all on GitHub, and this is just some of the features we're going to implement. And if I close this, then I can show you here on GitHub. So if you go to GitHub/procedural build/compute roadmap, you are taken here, and you can click on the roadmap, and then you can see and follow along in our development and the features we have. Yeah, so that's just a little extra before we begin. Just keep in mind that I'll be continually developing and adding features to Compute. So it's not only the things I'm going to show you today that we have. So today we're going to run this daylight factor simulation, and if you go to compute.procedural.build, then and scroll down to tutorials, then it's also possible for you to download and follow along or do it afterwards. You can go down to parametric daylight factor and to click download, and that's the case we're going to run today. I will share the link for the slides, and in the slides there's all the links to GitHub and to Compute and to this tutorial site. So I think it's time to go to Grasshopper and Rhino. So this is the 9 cases, offices or buildings we're going to simulate today, and they are not that fancy, but there is they all have have a different setup. So they vary in width, and they vary in height, and how much window space, or how much the window ratio is. So I did that by setting up a list and feeding it into down here. It's all standard Ladybug and Honeybee components. So I make masses out of the B-reps, I put glazing in, and I make test points or probe points to generate this. You can see here the mesh that we're going to get our source back in. And I create the honeybee recipe, and it's just a standard daylight factor today. And so it's not very fancy, but you can imagine how to elaborate on this and use the method to do even more advanced stuff, like first of all, a lot more cases and some generated design maybe, or you name it. So all this setup you can see here, that's labeled with the red 2 on, is honeybee things. and up here in the top, we have our own plugin, the compute plugin. And the compute plugin works by you log in, and you have a username and a password, and then you create your project and your task. So we're going to do it today that each of these 9 configurations are going to have their own task. And that is how we manage the separation of them. But they are all going to be in the same project, and we are going to call that project Parametric Daylight Factor. And each of the tasks have been the task names. I'm going to generate out from their parameters, so they will each have be named by the width, the height, and the window ratio. And before we start creating the task, I will just show you what it looks like when you log in. So I'll just log in and go to projects, and you can see here that we have a list of projects that I have already run or I am running, and the company that I'm associated with, and the amount of credits that we have. So you use the credits to pay for the simulation time. So we only charge people the time they use in the cloud for running the simulation. So it's free to have a user, it's free to sign up, and it's free to have your simulation stored at us. So what we charge for is to run the simulations. So I have already created this empty project right here. It's empty right now. And we're going to populate it with these task or simulation cases. So first we're going to create a task. So that creates the task. You can see here in the browser as well, and there's a little task created signal. And then we're going to write the radiance files, and we're going to write them to this path, and you can see the folder is created, and it is written by again standard honeybee component here, and we're going to use 4 CPUs, and our plugins is going to automatically detect how many CPUs is needed for this to run this case, and we just need to feed this component, the compute component, the folder where the radiance case is written to, and then the input from the project and task component. And then we're going to click here and say run and compute, and it should say down here, it says task created, and we can go here in the browser and see that it created a subtask to the task we have up here above. And you can see now that it's at green, and it says here on the status that it's initializing. That just means that the virtual machine that we run in the cloud is starting up. It's downloading the required packages it needs. It's connecting to our web server and so on, and it's kind of preparing, it's deploying. And if we go to files, then you can see that the compute component has uploaded all the files. So it's identical to what we have locally here. And you can of course look inside all the files, and it's the same. You can if you are doing something more fancy, for example, when you do CFD, you might want to be able to edit it. You might want to delete some files if something goes wrong, and you can also download each individual file through the browser, or the whole case folder. So now we need to create the rest of the cases. So we just created this first one. So we're just going to manually step through it, and it's a bit tedious to see, but it will just take a few minutes to do. And yeah, maybe if anybody has some questions while we do this, I can answer them. Otherwise, there will just be a few moments of silence. So let me go back to the first one. Let's see. Yeah, it looks like some of them we were a bit too fast with. We can take this one again. 10.5.5. Yes, and now that's graded 8, 7. So sometimes if you are a bit too fast, then it gets the files doesn't get uploaded before. The files doesn't finish to upload before you kind of change to the next one. So you just need to be a bit slower. But you can see now that the icons here, they change as we go along. So when it is this little sap, it means that the simulation is starting and that is actually running. And you can go here in the logs and see what's happening. And the logs, as you can see, stream back out to us. So we can monitor the progress of the simulation. And we can actually also go and see here you can see that it generates these result files, and that's what we're going to download in a minute. And if you go back to this, so you can see what actual radiance command is running, and we actually read this out from the radiance or honeybee setup case. So it's yeah, as you can see, besides changing and creating tasks, it's all done automatically. So while we wait for the last simulations to finish, we can start downloading the cases again. So just change back to the first one. So here we have our download component, and that is also connected to our you can see the green line here, our project and task, and that is how all the component that talks to the server needs what server, knows what server and what the password and user is and so on. It needs a download path, and the download path is go here to the files again. The download path is this path. Now we only have one folder, but it looks for this foam folder in the cloud, and then it downloads everything from that folder, which we don't have locally. And it downloads it, you can see here, to our local path, which is what I showed you before in here in Windows Explorer. And you can see here we have the result file downloaded, and then we feed this path into the Honeybee Daylight lookup folder, and we can refresh it, and then we read the results and we read the points out of that folder, and then we feed it into our recolor mesh, and we generate a legend, and you can see that we got our first simulation back. So we'll just go up and turn off the meshes. That looks a bit prettier. And then we're just going to do the same thing again. Going through and downloading everything. And you can see that there we got our next result back. Download. And six. Yeah, and now in the last one, refreshes, we have all our results downloaded, and we should be able to see here in the browser that everything is ticked off, and you can see that the task status is finished. Means the simulation has run to end, and yeah, we have all our results back down. You can inspect them. I made a little calculation of how much of the area is above 10% daylight factor, and you can compare the different solutions and pick the best one if you're going. It's kind of some design exploration, what you're doing. Otherwise, yeah, you can continue with your analyses. Yeah, that was basically what I had today. There's not so much to show, or like there's not so much happening in the canvas. It's more or less up to you. The more, of course, the more complicated setup or like building you have, the more ladybug and honeybee components you need. And that's right now it's quite small setup I have here. But of course it grows, and you have applied different materials and so on. I've just chosen some of the default ones that will grow, but these components that interact with compute, they are basically staying the same. So we have our login and our projects and the running compute and the download component, and they can be reused as much as possible, or like for every case you have. So it's up to you to be creative on the on the building side. Yeah, that was what I have. I realize it's a bit short, but if there's any questions, we can take them. Otherwise, that was what I had. Oh yeah, before we stop, I can share the link to the slides. There's a bit more slides than I showed. There's the last slide is without links. And yeah, so you can later go in and look at the things I showed you today. Yeah, if there's no no questions, then we're going to stop for today. Thank you very much, everybody, for watching, and see you next time.